Now I'd like to deal with three layers where the index of refraction in the third layer is greater than the index of refraction in the second layer, which is greater than the index of refraction in the first layer, which means that you're going to get inversion as it bounces off of the bottom layer, because the bottom layer has a greater index of refraction than the layer above it, and you're going to get inversion when you bounce off the top of the second layer, because the second layer has a greater index of refraction than the top layer. So you're essentially going to have two phase shifts, and the two phase shifts are going to cancel each other out. So that you end up getting destructive interference with the condition thickness is equal to 1/2 lambda over n, or the wavelength in the center medium, times an index 0, 1, 2, 3 integer, plus 1/2, or if you want to simplify it out, I guess you could write it as being lambda over 2n, where n is the index of refraction for the center medium again, times an integer 0, 1, 2, 3, etc., plus 1/2. And of course the constructive interference criteria would be a thickness of m lambda over 2n and that's specifically when you get an inversion both at the top layer of reflection and at the bottom layer of reflection. What we looked at previously, which seemingly had the same equations in reverse, was when you only got reflection at one of the positions, either the top or the bottom. Okay? So let's take a look at the first thickness for which destructive interference happens. We're talking about having a thickness where m is equal to 0 of lambda over 2n. Let's let m equal 0, so we would have 0 plus 1/2, or we would just get lambda over, well, 1/2 times 2, or 1 over 2 would be 1/4 n. So a quarter of the wavelength in the particular medium. That would be the first condition for destructive interference to occur. The first or thinnest thickness for which constructive interference could occur, again, would be this trivial case where 0 times lambda over 2n would just mean that there's a thickness of 0, where the index of refraction is greater in the bottom layer than it is in the top two layers. Now the next non-trivial thickness for constructive interference would be when m is equal to 1, and so that would be thickness is equal to 1 lambda over 2n, or half of a wavelength. So half of a wavelength of thickness in this center medium would be the first non-trivial constructive interference point. I mean, to say that you have a thickness of 0, I'm just saying it's a little bit trivial.